Okay, question number 9 says we have to rearrange them. I am not going to read the question because you won't understand anything. Let me solve one and then you will know what the question says. Now, this might look a little funny. All are arranged variable, constant, variable, constant, variable, constant, variable. If no sign is there between them, we know that by default there is multiplication sign. Now what the question says is, first arrange the numerical coefficients, or simply saying, first write down the constants. So in this the constants are 3 into 2 into 4. The numbers. Okay, so we say constant means numbers. And then comes the variables. P, and these variables also you have to write it alphabetically. That means P should come first, then will come Q, then R, then S. Okay, this is called arranging alphabetically. As it is in the English alphabet, P comes first, then Q, then R, then S. Okay, the final answer will be, you can multiply these constants. 3 2s are 6, 6 4s are 24. So 24 P Q R S. So the meaning of this is this, after arranging. When you arrange it, it will be like this. So this is what the question says. First, the numerical coefficient should be there, then the literal coefficient should be there. The next one. Again I say, if there is no sign, there is always multiplication sign. So in this one, numerical coefficient will be first. So I will write 15 first. And then the literal coefficients, that also arranged in alphabetical order. So C, D, E, F. So the final answer will be 15 C, D, E, F without the multiplication sign. Without the multiplication sign. Okay, coming to the next one. Again I say, no sign is there, always multiplication sign is there. So now we will arrange writing the numerical coefficients first. What are the numbers? 4 into 2 first. Followed by the literal coefficients, variables I am going to say. So that also you have to arrange alphabetically. So what are the variables here? X, Y and Z. So X comes first, then Y, then Z. So our final answer will be 4 2s are 8, X, Y, Z. This is how we arrange. Okay, now this one, this 2, 5 W 2T. And as usual, no sign means multiplication sign is there. So first we will write the numbers. Okay, now W and T, which comes first among W and T? R, S, T, U, V, W. So T comes first, followed by W. So when the final answer, it will be 5 into 2, 10. T into W is TW. This is how you arrange the terms. And by the way, each of these terms in the given expression are known as factors. P is a factor, 3 is a factor, Q is a factor, 2 is a factor, R is a factor, 4 is a factor, S is a factor. That's why the question it says, rearrange the factors. Each of these terms are factors of the whole expression. Okay, like here, 24 is a factor, P is a factor, Q is a factor, R is a factor, S is a factor. Alright, I hope you have understood. Okay, next comes about identifying which are actually algebraic expressions. Now, algebraic expressions can be monomials, binomials, trinomials, or simply we can say as polynomials, depending on how many terms are there. Okay, but in that also we have to select whether it can be a polynomial or not. Okay, whether it can be a polynomial or not, or in other words, whether the given expression is actually an algebraic expression or not. Now, for a given question to be an algebraic expression, there should not be any term in the denominator as variables. That means an algebraic expression cannot have a variable as a denominator. Any variable can be there in the numerator but not in the denominator. Denominator variable, then it's not a polynomial. Like we say this example, the first part. Here there are three terms, alright, but in this one the variable is there in the denominator, in one of the terms. Among the three terms, the second term, you see, there is a variable in the denominator. So this is not a polynomial. It's not an algebraic expression. So I am going to write here not polynomial. Okay, this is fine. There is a denominator and there is a number in the denominator. Numbers are allowed, not variable. If there is a variable in the denominator, then the whole expression is not a polynomial. So this one is a polynomial. This doesn't have any denominator as such, so it qualifies to be a polynomial. Okay, there is no denominator, so no question of variable being in the denominator, so it's a polynomial. Then comes this one. Again, here you see in the denominator there is a variable. Okay, 1, 2, 3, 4, 5 terms are there. Out of these, the first two terms they have their variables as denominator. This is not allowed. So, not a polynomial. This one is alright. There is no denominator as such. So, no question of a variable being in the denominator. So, it's a polynomial. Again, the sixth part, you can see one of the term has a variable in the denominator, so it disqualifies. It is not a polynomial. Okay, the last question of this exercise, it says here write down the degree of the following polynomials. Now here is a polynomial, it has 1, 2, 3 terms. Now to find degree, we need to look at the powers of variable. But you will say, sir, where is the power over here? There is no power. There is power, okay? A's power is 1, B's power is 1, B's power is 1, C's power is 1, C's power is 1, A's power is 1. If there is no power written along with a variable, always remember there is this 1 always there. And in mathematics, this 1 we don't write in many places. So likewise here 1 power is there, but it is not written there in the question. But we have to know that there is 1 power. Now for finding degree, we have to look at the powers of each term. So now this particular term, the power is here 1 and 1, 2. So we add the powers. If there are multiple number of variables in each term, so both the variables power we add. Similarly here also, B's power is 1, C's power is 1, so together we have 2. Here also. So in general, the sum of the powers in each term is 2. So the degree of this is, this particular polynomial's degree is 2. Okay. Next. Here there is only one variable t, and so its power is 2. If there would have been other variables, then we could have checked for them, but there is only one variable over here. Its power is 2. So degree of this polynomial is 2. The next one, the third one, 3x squared minus x to the power 4. Okay, now here two terms are there. In this one, the degree of the x is 2. Here, the degree of x is 4. Now comes the interesting part. Which power we will select as the degree? The highest power. Okay, the highest power. So in this one, the highest power is 4. So degree will be 4. Alright. In this case, in question number 1, there was no highest power. For this one also 2, for this term also 2, for this term also 2. So in general, the degree of this polynomial was 2. But in this case, both the variables x have different powers. So we select the highest of the two. The highest power of the two. Question 4, part 4. 3p square plus 5p cube plus 7p to the power of 5. Okay, here there are 3 terms. Now this term has only one variable, and what is its power? 2. Alright. Should erase all this. Okay, for this particular term, the power is, the variable's power is 2. For this particular term, the variable's power is 3. For this particular term, the variable's power is 5. So now we have 3 different terms having 3 different powers. So which is the degree? Degree is the highest power. So which term has the highest power? This one. So degree is 5. Okay. So this is how we write down the degree of a polynomial. Alright. Now question number 11 part 5. Only 4 is there. Is there a variable here? No. No variable. No variable means no power of variable. No power of variable means degree is 0. Degree is selected out of the powers of variables. But if there is no variable, that means there is no power also for that variable which is not there. So degree is 0. Alright, coming to 6th number. Alright. Two x square plus x y z plus 3y to the power of 3. Okay, now for this one, the x power is 2. There is only one variable in the first term. In the second term, there are 3 variables. So 1, 1, 1. X power is 1, y power is 1, z power is also 1. So together 1 plus 1 plus 1 is how much? 3. And here, this term has only one variable, and that variable y, the power itself is 3. So power in this term is 2, in this term 3, in this term it is 3. So out of 2, 3 and 3, of course the highest power is 3. So degree of this particular polynomial is 3. Okay, degree is the highest power. Last one, number 7. A square b plus a to the power of 3 b to the power of 2 Now for this one, let us see each of the terms. Now for this particular term, you have two variables. Okay, a power is 2, b power is 1. So for this particular term, sum of powers will be 2 plus 1, that is 3. For this particular term, a's power is 3, b's power is 2. So 3 plus 2 is 5. For this particular term, there are two variables a and b. A's power is 1, b's power also is 1. So 1 plus 1 is 2. Now out of these, which term has the highest power? Obviously the second one, 5. So degree is